Greetings everybody and welcome back to another exam video. Today we're taking a look at the 2022 Methods Exam 2. So I'm only doing section A, so multiple choice section in this video because I can't be stuffed doing the whole thing in one sitting. So extended response, which is section B, will be out in another video, hopefully sometime soon. But yeah, I've taken a quick look through these questions already and they don't look too bad. Fairly standard sort of questions. I'm assuming a lot of people would have done quite well with this section. I don't know about section B though. Maybe they made it super hard, but yeah, who knows? I'll find out when I do those questions. Anyways, let's just jump straight into it. Question 1, we have everyone's favorite trig question. We're given a Cosmograph or a cos function and we're asked to find the period. How do you do that? You just take 2 pi and you divide it by the coefficients in front of x, which is a 2, and the answer is precisely pi. Question 2, the graph of this truncus has horizontal asymptotes at, well, horizontal asymptotes is y equals something, and that something is precisely the vertical translation, which in this case you can just read off as 4. So it's going to be option A. Question 3, the gradient of this exponential graph at the point where the graph crosses the vertical axis is equal to. The vertical axis, that's precisely the y-intercept, and the y-intercept occurs at x equals 0. So we're going to differentiate this guy to get the gradient function and just evaluate at x equals 0. So dy dx, what is that going to be? That's precisely 3 times e to the 3 times x. That's using a bit of a chain rule there. And then we just evaluate this guy at x equals 0. So what happens if you plug 0 into that exponential function? You get e to the 0, which is 1. And then you still have this 3 here. So 3 times 1 is 3. So it's option E. Okay, question number 4. What do we have? We have which one of the following functions is not continuous on this interval 0 to 5? First of all, it's not going to be sine, because sine is continuous everywhere, and the square of a continuous function is also continuous. It's not going to be the cube root as well, because what does the cube root look like? It looks something like this over here. It's continuous everywhere. Just be careful. It's not differentiable at 0 though, because you can't draw a gradient there. It's going up like that. So it's not differentiable there, but it is continuous there, so it's continuous everywhere. So how about option B? Well, option B is a cube root graph a square root graph starting at x equals -3, which is over here, and then it goes off to the right, so it's obviously going to be continuous on that right hand side there, so it's not B. And then finally option A, well, that's going to be a truncus with an asymptote at x equals -3, and well, a truncus is continuous everywhere except for that vertical asymptote, so it's going to be continuous on 0 to 5. So this leaves us with option D. Now, you can check that it is indeed option D just by finding the asymptote. A nice way to do that if you have the CAS programs. Link in the description if you want to find out more about them. Let's use the analyzed program, and I'll put in tan of x, comma 0 to 5, and I'll approximate to this. And if you scroll up a little bit, you'll see that we have our asymptotes at 1.5 and 4.7. So obviously, we're not going to be continuous on that interval. Okay, so it's option D. Question 5, the largest value of a such that this function, this quadratic, is 1 to 1. So this is a classic type of 1-to-1 question involving polynomials or quadratics in this case. So let's think about it. Our quadratic is going to look like this somewhat. It's a positive quadratic, and we're asked to find the interval. Well, we're going from -infinity back to a, inclusive. And the question is, how far can you push a to the right? In particular, what's the largest value of a such that this whole graph here is still 1 to 1? Now, you definitely don't want to go past that turning point there, because once you go past the turning point, you're going to fail the horizontal line test. So it's not going to be 1 to 1 anymore. So the largest value of a, where this is still 1 to 1, occurs precisely at the turning point, and the turning point of a quadratic you can compute very easily using the formula minus b over 2a. Minus b over 2a is minus 3 over 2 times 1, which is 2. So that's going to be minus 1.5. Question 6. Which of the pairs of functions below are not inverse functions? So just be careful, these are not piecewise functions, these are just pairs of functions. So which one of these pairs are not inverse functions? So I guess the best way to do this is just go through them one by one. So f and g over here, how do you find the inverse of 5x plus 3? Well, you just rearrange. Imagine you set this equal to y and rearrange and make x the subject, and that gives you something like you have to subtract 3 from both sides first of all, or actually that's y minus 3, then divide by 5. And replacing x's with y's, interchanging those, that gives you this correct function over here. And how about with the second one? Well, it pretends this is equal to y and solve for x. And if you do that, you're going to get y minus 2. And then you still have to multiply everything by 3 halves. So 3 halves, then multiply by the whole thing. That gives you x equals that guy. But this is equal to 3 halves y minus 3. Well, that's exactly this g down here. So that's good. How about C? Well, this is an x squared over here. We have x squared on the negative side. Let's draw it a bit of a picture. So we have x squared on the negative side. And what do we expect the inverse function to look like? Well, it's going to be plus or minus the square root. But we're going to take the negative branch because this needs to be reflected in the line y equals x. It doesn't make sense for the inverse to be the positive branch of the square root. But you see a bit of a problem over here because this is the positive branch of the square root, which we don't want. So this needs to be a negative here for this to be an inverse. So it's going to be option C because that doesn't work there. And you can check D and E as well. These pairs of functions are inverses of each other. 1 over x is its own inverse, and you can quickly verify this is inverse as well. Okay, so that's question 6. Question 7. The graph of y equals f is shown below, and we want to find the derivative. Well, how do you do these sorts of questions? Turning points on the original graph correspond to x-intercepts on the derivative graph. There's 2 turning points, so we're looking for 2 x-intercepts. So first of all, A is not going to be the answer, C is not going to be the answer. It's not going to be D as well because we're not going to get asymptotes in our derivative because just look at this, the derivative is defined everywhere. So it's either B or E. And let's just take a look at one of these turning points over here. So this rightmost one, on the B and D graph, will correspond to these 2 points here. Okay, and just take a look at the gradients on both sides. So we're going from a negative gradient to a positive gradient on the right-hand side. B doesn't work because our derivative graph is above the x-axis, then it goes below the x-axis. E works because we're going from below the x-axis to above the x-axis, which reflects the gradients we have up over here. So in that case, question 7, the answer would be E. Alright, question 8. What precisely do we have? We have some integrals, and this is an integral from 0 to b, and we also have an integral from 0 to a of the exact same function f. Then we want to find the integral from a to b. Well, that's quite easy because the integral from a to b, let's use a pen and pen here. The integral from a to b of f of x dx, that's exactly the integral from 0 to b of f of x dx minus the integral from 0 to a of f of x dx. But we know what each of these guys are equal to. That's exactly 10 minus negative 4, but that's a 14. So it's going to be option E. Okay, question 9. We have a square root graph, and we want to find the shortest distance d from the origin, which is this O here, out to some points xy. The shortest distance d, that's exactly the length of the straight line segments. So pretty much all you need to do is find the distance between the points 0, 0 and x, y, but we know exactly what y is in terms of x because it lies on this function. Y is going to be precisely square root of 2x plus 1. So you just use the distance formula for these 2 points, but if you have the programs, you can just plug this into linear info, and you don't have to worry about pressing square root buttons and all that kind of stuff. So you go to linear info, you type in 0, 0, comma, and we'll type in x, comma, the square root of 2x minus 1, which I believe was 2x plus 1 actually. And we do that, click enter, then it should give you the distance right over there. It's the absolute value of x plus 1. We don't have to worry about x being negative because our function is defined on the positive numbers, so we don't have to worry about absolute values, which means that the answer is precisely x plus 1. Alright, question 10. An organisation randomly surveyed 1,000 Australians, found 55% of those surveyed were happy, and we want to find some kinds of 95% confidence interval. Okay, so we're given we're given some kinds of sample size, which is 1,000. We're given the sample proportion, which is 55, and we're asked to find the confidence interval. So you just got to plug that into the one prop z test on your CAS. So to do that, you can go to menu 6, and then you go to confidence intervals. So that's menu 6. Then you're just going to use one prop z interval, like so. Successes. Now here's the problem. We're given a proportion, not the number of successes. So you do have to convert that. That's going to be 1,000 times 0.55. N is going to be 1,000. That's your sample size, and that's the confidence level. And what we've got, 0.51, 0.58. Matching that up, it is precisely going to be option D. There's also a better way to do this as well, using the programs where you don't have to do that conversion there. I'll show you guys quickly. So you can go to method stats, confidence, and you just type in, well, sample size, which is 1,000, sample proportion, which is 0.55, then confidence level, which is 95. And you get the exact same interval. The nice thing about using this program is, well, you could either put in the number of successes, which I believe in this case would be 550, and it interprets it appropriately. So it interprets that second input there. If you put in a number greater than 1, then it's going to assume it's the number of successes. Otherwise, if it's between 0 and 1, then it's going to assume that it's a proportion. And that 95 there as well, if you put in 0.95, then it still works, because it'll interpret that 0.95 as a confidence level, because you're not really going to ever use a 0.95% confidence level anyways. Okay, so that's question 10. Question 11. What is this? This is the integration by recognition question. Okay, so to do integration by recognition, you're given this derivative equation. You just got to integrate to both sides. So integrating the left hand side, it gives us x times the sine of x. Integrating the right hand side gives us the integral of sine of x dx plus the integral of x times the cosine of x dx. And we're after some kinds of integral involving x cosine of x. So let's isolate this guy, and that gives us the integral of x cosine of x dx equals x sine of x minus the integral of sine of x dx. Okay, but we want a 1 over k out over here, so let's pop that in everywhere. So 1 over k, 1 over k, 1 over k. And let's just match up the answers. So we want, let's see, A wouldn't work because we want 1 over k, not k. B wouldn't work because we want a 1 over k in front of the integral of sine, whereas this doesn't have it. C looks like that's the correct answer because we have 1 over k multiplied in everywhere. D wouldn't work because, well, the integral of sine, first of all, is negative cosine, but this just leaves it as sine, and E wouldn't work either. So it's going to be option C. Alright, question 12. A bag contains 3 red pens and X black pens. So let's think about this a little bit. We have 3 red pens and we also have X black pens. 2 pens are randomly drawn from the bag without replacements. The probability of drawing a pen of each color is equal to. First thing I think of is tree diagram, because each time you choose a pen, you're going to change the probability. So let's represent this in a nice way. So how does the tree diagram look? Well, there's 2 options first of all. You could either go for a black pen, or you could either go for a red pen, black pen, red pen. And then what we want, you could have 2 branches coming off of this. Now, you don't have to list out all the branches, you only list out the branches you're interested in. In particular, I want from the black branch, I want to go down to the red branch next. And from the red branch, I want to go up to, or I want to go to the black branch, because I only want 1 of each color, drawing a pen of each color. Right, so I don't want 2 blacks or 2 reds. Okay, so from here, we're just going to calculate probabilities, multiply everything across, and add together. So, what's the probability of picking a black pen initially? It's going to be, well, there's going to be 3 plus X pens in total. And, well, how many black pens are there? There's X of them. How many red pens? There's 3 of them. And in the next branch, there's going to be 2 plus X pens left. So we'll put something over 2 plus X. Now, we're going to pick a red pen. The probability of doing that is actually 3 over 2 plus X, because there's still 3 red pens remaining. We haven't touched them at all after the first choice. And similarly for the black pen, there's still going to be X remaining, because we didn't touch the black pens on this branch over here. So just multiply across, then add together, it seems like. So let's see, we have fraction times fraction, and then plus fraction times fraction. Let's fill in the blanks over here. So we have x over 3 plus x, and then something over 2 plus x, that's 3 over 2 plus x. I should really make a CAS program for this because this is quite tedious actually. So 3 over 3 plus x, then it's something over 2 plus x, that's going to be x over 2 plus x. Okay, and that gives us 6x over x plus 2, x plus 3. Looking at the answers, it's going to be exactly A. Alright, question 13. The function f, some kind of funny log function where a is a positive real constant, has maximal domain. How do you find maximal domain on the CAS? Just type in domain, then plug in your function, which in this case, you can use ln for log, and we have x plus a and x minus a in here, and then do comma x, and then we get some funny output over here. Maybe it's useful if we put in the condition a is a positive real constant, so let's do that. We'll do such that a is greater than 0. And what do we get over here? We get x is between negative infinity and negative a, and x is between infinity and positive a. Okay, so if you draw out a little interval diagram, what does that look like? I believe it's exclusive. Yeah, it's exclusive negative infinity to negative a, then a to infinity. We look at the answers, well, none of these match up with what we want to. Actually, it's going to be either C or D, because this interval we drew over here, this is all the real numbers, but we're going to take out a specific interval, namely the interval from negative a to a inclusive. So it's going to be option C. It's not going to be D, because if you take out an interval excluding endpoints, then you're going to be still leaving the endpoints negative at a and a in the interval that you want. So you want to take them out. It's going to be option C. All right. Question 14. Continuous random variable. Here's the PDF, and we want to find the expected value. So that's just a nice and simple computation you can do. What you can do, you can define f of x to be equal to, that's going to be 2/9 times, and let's do x times e to the negative 1/9, and then we also have x squared. Okay, and well, there's a few ways you can do this. First of all, we can do integral from 0 to, in this case it's going to be infinity, 0 to infinity of x times f of x dx. Technically, you're supposed to go from negative infinity to infinity, but notice when x is negative, your function is going to be 0. So you can actually cut off at 0 and just go from 0 to infinity, because that's, in probability theory, that's called the support of your function, because it's not a 0. So it's going to be 2.65. Okay, and another way to do it, which maybe it's a bit faster than having to type in this integral, is you can go to method probability, go to continuous info, then just type in f of x, comma x, comma, well, where are you interested? 0 to infinity, and it gives you expected value, which is the mean. That's 2.65. Let's go with option B. All right, question 15, maximal domain again. So, well, that's fairly simple. Just type in domain of the square root of x squared minus 2x and minus 3, and comma x, and we get this interval here, or this set. It's negative infinity to negative 1 inclusive, then 3 to infinity. And just looking at the answers, it's going to be option E. So we're going to negative 1 inclusive, then 3 off to infinity. Perfect. All right, question 16. We're given a cubic, and we have some unknown parameters, m, n, and p. The turning points, we're given some information about this cubic. It has turning points at negative 3 and 1, and also it passes through the point 3, 4. So I'll show you guys a nice way to do this one. First of all, what you can do is to find this function f of x. So to find f of x equals, that's going to be 1/3 times x cubed, then plus m times x squared. Make sure that you have a multiplication between m times x, otherwise the CAS will treat mx as one big variable, which it's not. We also have n times x, then also plus p. So this is our function, and because we want something to do with turning points, I'm going to define the derivative of this guy as well. So I'm going to define df of x to be equal to the derivative, which is shift minus with respect to x of f of x. Okay, And now, usually what you do from here is you just plug this into systems of equations or something. There's a much quicker way to do that. You can just type in solve or menu 3.1. Now, what conditions do you want? Turning point at -3 means the derivative at -3 equals 0. And what else do you have? We have a turning point at 1, which means derivative at 1 is 0. And we pass through 3, 4, which means f of 3 equals 4. So you can just type in this whole string over here. You can just type in ands between all the conditions that you require. You put a comma, then you list all the variables, which is going to be n, m, and p. Okay, and maybe I should put it in the other order because that's the order the question had. So m, and then n, and p. And if you do that, well, it gives you m equals 1, n equals -3, and p equals -5. So that's going to be option B. All right. A few more questions to go, like 4 more questions. Question 17, a function g is continuous on the domain a to b and has the following properties. The average rate of change of g between a and b is positive. What does that mean? It means if you draw some function g over here, it means that if you draw a line from these two endpoints, a to b, it's positive, so it's going upwards. That's basically the average rate of change. What else do we have? The instantaneous rate of change. So the derivative now, the gradient, at the mean of a and b, so the middle of a and b, is negative. So I kind of drew the wrong picture here. It should look something like this here. So the average rate of change is still positive, but the gradient at that midpoint of a and b, that's going downwards now. Okay, so therefore on the interval a to b, the function must be, first of all, it's definitely not strictly increasing or decreasing. We're doing like a wee-woo over here, so it's not going to be any of those. It's not going to be 1-to-1, because to be 1-to-1 you need to be always going up or always going down. We can't be, going up and down at the same time. So it's not, actually, why am I circling these? It should be x's. It's not 1-to-1. It's either 1-to-many or many-to-1. Now, 1-to-many means every x value has multiple y values, but that can't occur because this is a function here. So functions can only be many-to-1 or 1-to-1. So it's going to be many-to-1. Okay, question 18. X is binomial with n equals 20, p equals 0.88. And we want to find this probability here. We want this probability to be 0.9175. Okay. You could write out conditional probability here. So PRX is greater than or equal to 16. Intersect x is greater than or equal to a divided by the probability that x is greater than or equal to a. And we want this guy to be equal to 0.9175, and we want to find the value of a for which this occurs. Okay, how do we do this? I guess the best way to do this, because there's only like 5 numbers here, just to do trial and error. I don't know if there's a better approach to this. Maybe inverse binomial, but it's going to be a little bit tricky to use that if you don't know how to do that. So let's just define. Also notice as well, all these numbers that we're going to plug in via trial and error, they're all less than 16, which means if you take a look at this intersection here, what's the intersection of x greater than or equal to 16 and x being greater than a number less than 16? Well, this second part is kind of redundant if you really think about it, so we can ignore that. So let's define, let's say p of x equals, and we want the probability that x is greater than or equal to 16 first of all. So I'll do menu 5, and I'll do b, and I want a 20.88. Lower bounds is 16 up to 20. So I'll do that first of all. Actually, that's not my function yet, because I also want to divide by. We'll go menu 5 and b once again. We'll do 20 still, 0.88, but now my lower bound is going to be some number a. Actually, because my function is depending on x, I'll put an x over here, then my upper bound is 20. Okay, so if we do that, here's our function p of x. This is basically the function we just wrote down. And what I'll do is I'll just do p of 11, 12, 13, 14, 15. So you can evaluate, you can do p of 11, p of 12, and so on. But if you want to evaluate on multiple values, you can use a list. Do 11, 12, 13, 14, 15. and argument mismatch, because maybe binomial can't handle that, unfortunately. So never mind, we'll do P of 12, P of 13, P of 14, and P of 15, and let's see which ones match up over here. Well, it's going to be, we wanted 9175, looks like it's going to be 12, that's the closest one. So let's take 12. Alright. Question 19. A box is formed from a rectangular sheet of cardboard, which has a width of A unit and a length of B. Which way is width, which way is length? I forgot. It doesn't matter. I'll just do A and B over here. And we want to cut out squares of side length X. So we're going to chop out these squares here of side length X. And I believe we're just going to fold it up. Alright. Yeah, it's going to fold up to form a container with an open top. We want to find the maximum volume of the box and the value of X for which this occurs, actually. So first of all, how do you find the volume of this guy? Well, it's length times width times height. The length of this box is going to be A minus 2x, because that's the total length. We subtract off the 2x, 1x from both sides. Then we do B minus 2x, and then we have x. So this is the volume function, V of x, let's say. Let's define that on our cas. We will define V of x to be equal to A minus 2x, then we have B minus 2x, and then times x, like so. And we want to find the maximum volume of this box and the value of x for which this occurs. So you just differentiate to this guy and solve the derivative that equals 0. So I'm going to solve the derivative with respect to x of V of x equals 0 with respect to x. That gives me some stuff over here. So this gives us two solutions, which is expected because this is a cubic. So this corresponds to two possible stationary points that our cubic could have. One stationary point is going to be a local maximum, one stationary point is going to be a local minimum, and we need to figure out which one it is. So first of all, which one's the positive one, which one's the negative, or which one's the one to the right, which one's the one to the left. Notice we have A plus B over here, then we have plus a square root, whereas on this first solution we have A plus B if you distribute this negative in, so A plus B, but then we have minus a square root. So this first solution here, that's going to be the leftmost stationary point, and this right solution here, that's going to be the rightmost stationary points. So the best way to determine this, I guess, is you can use the double derivative, I think, but that's something you do in special, I believe. So what you can do is go to insert a new graphs page, and we'll just put in V of x over here and see what pops up. We'll create sliders, and already if you just stare at that, you will notice that there's two stationary points. There's going to be one to the left. The leftmost one is going to be a local maximum. The one to the right is going to be a local minimum. So you can slide the sliders around and you can see that. I guess another way you could see it as well is notice this is going to be a positive cubic because we have a negative x and negative x. So that's a positive leading coefficient. So it's a positive cubic. And if you have a positive cubic with the two stationary points, it's going to look like this. The leftmost stationary point is always going to be a local maximum. So we're going to choose this leftmost stationary point here, which is A plus B minus a square root. A plus B minus a square root. It's a B in there, so it's going to be option D. So it was either D or E, but E had the extra 2 in there, which we don't want. That's option D. Alright, what are we up to? Oh, question 20 already. Question 20, a soccer player kicks a ball with an angle of elevation of theta, where theta is normally distributed random variable, with a mean of 42, standard deviation of 8. First of all, I don't like how they use lowercase theta for that. I'm going to use the big boy capital theta, that Greek letter capital theta, if you've seen that before. So that's the capital theta, and this is normally distributed with a mean of 42, standard deviation of precisely 8. Okay, and we're also given this equation here, but because theta is just a number from this random variable, we can rewrite this equation in terms of random variable. We're going to have a random variable d, which is equal to 50 sine of 2 big theta, where theta is the random variable. Now what exactly do we want to do? We want to find the probability that the ball travels more than 40 meters horizontally before landing. Okay, so we want to find the probability that d is greater than 40. That should be it. But we don't really know the distribution of d too well. We do know the distribution of theta though. So let's write d in terms of theta and see what we get. That's the probability that 50 sine of 2 theta is greater than 40. Alright, so I just substitute d for this expression in terms of theta. And let's rearrange things now. I want to get theta by itself somehow. Maybe that's possible. So this is sine of 2 theta is greater than 40 over 50, which is 4/5. Okay. And, well, now we need to figure out what values for theta would make sine of 2 theta greater than 4/5. You do have to be a bit careful here because theta is measured in degrees. So if you're on the blue cards, you can just click this little button up over here to change it to degrees, but be very careful. You have to change it back to radians after you're done with this question, otherwise, yeah, it won't work out for you too well if you do the rest of your exam in degrees. Otherwise, you can just open if you don't want to mess around with that, you can just open a scratch pad over here, change it to degrees, or you can go to document settings and change it to degrees and play around in here. And what do we want to do? We want to find when sine of 2 theta is greater than 4/5. So let's do that. We're going to solve the sine of 2t is greater than 4/5 with respect to t. And this is going to give us some kind of general solution probably. So I do want some restrictions on t, which is theta. First of all, it's an angle of elevation. So let's just assume that t is between 0 and 90. So 0 less than t less than 90. And, oh dear. Maybe this is one of the times when the CAS doesn't like solving inequalities, so we'll solve for equality instead. And we get these two solutions. Now, if you think about the graph of sine of 2 theta, it's going to look something like this. So here's my axes over here, and here's my sine of 2 theta, something like that. I believe this should be, yeah, that should be 90 there. And, well, for this to be greater than 4/5, which is probably a line up over here, we need it to be between two values, namely, well, where we intersect 4/5. So right in this region here. And, well, that's precisely that endpoint. Those endpoints are 26.565, and that other endpoint over there, that is 63.4349. Which I won't bother writing down. So, in order for sine of 2 theta to be greater than 4/5, we require that theta is between 26 and 63, those two numbers there. So he wants 26.565 less than theta, less than 63.43. So now because theta is a normal random variable, we can just evaluate this probability directly, which is quite straightforward. Something you can do, instead of having to type out these numbers again when you do the normal distribution, you can just define them straight away. So I'll define A equals, I'll grab this number here, and I'll set it equal to A, and I'll define B equals, I'll grab this other number, and I'll enter it in. Okay, so now if I go to menu 55 normal, which is 2, menu 552, my lower bounds I can just type in A, my upper bound I can just type in B. And what's the mean? I believe it was like 42, was it? Yeah, 42. And the standard deviation is precisely 8. Click enter, and 0.969, which we can, yeah, it's obviously going to be option A. Alright. So you just got to transform your random variable for this one and rewrite it in terms of a random variable you know. That's pretty much it. So that's all for multiple choice. That was a pretty straightforward multiple choice section, actually. Probably one of the easier multiple choice sets out there. So yeah, a lot of people would have done well for this section. So I'll take a look at extended response in the next video. Don't know when that will come out though. Maybe it's a bit more spicier than this one, but yeah, that's all for this video. Hopefully it helped, and I'll see everyone in the next video. Bye bye.